Hello friends, today we are going to show you an amazing experiment how to measure current in a circuit. First of all, we will check the cell whether they are in perfect condition or not. After that, we will do the experiment. First, we will check the voltage of these cells. After that, we are going to make an experiment how to measure DC current, right? Let us check first the voltage of this cell. This one is 4.75 volt. It's okay. We'll check this one whether it is in perfect condition or not. It is 0.01. It is not in perfect condition. Let us check this cell how much it is. Let us check, and we are getting 5.40 volt, right? It is okay. And we'll check this one also. This is how much. Let us check the voltage of this cell, and we are getting nearly 8.16 volt. We will use these three cell here, right? Now you see how to measure an DC current. That is our job, right? For that you have to know that an ammeter measure current, and you see this is a digital multimeter. This can also measure the current in a circuit. Now we'll make a circuit and we'll show you how to measure the different currents with these equipments. You see we have a motor here. You can see here this is a motor. You can see that there is a buzzer. You can see there are two propellers. You see there are two propellers. One switch is there and one LED is there, right? With this we can show you how to measure current in a circuit. First of all, you have to know that ammeter is an instrument which measures the current. Here you can measure the current with this digital multimeter. But before that, you have to know that in which type of connection you can measure the current. You have to remember that current or DC current can be measured only in series connection. You cannot measure in parallel connection. We can measure the parallel connection for measuring voltage, but for measuring current you have to remember that this digital multimeter should be in series connection. Let us see how we can make a series connection with it and show you how we can measure the current. Before that, you can read this digital multimeter. You see, in this digital multimeter we have DC current. You can measure the DC current here, right? Here you can see the range from here to here, that is 2000 microampere. This is 20 milliampere. This is 200 milliampere, and this is 10 ampere. For measuring 10 ampere current, you have to take this red one with this probe, because this is 10 ampere, right? And this range is from here to here, that is 2000 microampere, 20 milliampere, and up to 200 milliampere, right? Now we'll show you how to measure the current in this digital multimeter. Here you can see that there are other sections also. This is the measuring for measuring DC voltage, and it is measuring it comes from 200 millivolt, 2000 millivolt, 20 volt, 200 volt, up to 1000 volt. You can measure the DC voltage, and you can also measure the AC voltage here also there, and the range is from 200 to 750 volt. You see, this is the symbol of AC, like a wave, and a straight line. This is a DC voltage. And you can see here that there are other sections also. You said in these sections you can measure the resistance, and the range varies from 200 ohm to 2000 ohm, 20k, 200k, and 2000k. You can see this is the continuity and the symbol of diode. You can measure the continuity test in this section, and you can also measure the square wave in this section, and HFE, that means beta value of a transistor of NPN and PNP transistor, with this digital multimeter. But now I will show you how to measure the current in a circuit. Besides, remember that you have to put this digital multimeter in series to measure the current. Let us make the circuit and you see how we are making the circuit with these various wires and how to measure current. First of all, to measure the current, you have to put this probe into the 10 ampere because we don't want to, you have to take it on 10 ampere. You see, this is the 10 ampere range and you take this probe and place it here to measure the current up to 10 ampere because we measure the maximum current first. After that we will get the actual current. You see here, we put it here on the 10 ampere range. You see here, this is our knob and we put it here on the 10 ampere range. You see, this is 10 ampere range, right? Now you see what you have to do. You have to connect this arrangement in such a way that the multimeter should be in series connection. Only then you can measure current, otherwise you can't measure the current. You see, we are taking this multimeter in series and you will see how we are going to measure the current. Put any load in series. After that you can check it the various voltage, various current. You have to put it in series connection. First of all, we will put this buzzer in series. We are going to put this buzzer in series. After that we are going to measure the current. You see here, first of all we will join this one, right? We have joined this negative probe with this buzzer with the negative, right? And after you see that this one is positive probe, right? And if you want to measure the current, you can measure the current also here. We are taking this cell and see, we will connect this one in series and you see how we are going to measure the current in this. You see how we are connecting. We are connecting this buzzer with the series. This is the red, means positive, and we are going to make this with the positive cell. And you can see, if we touch it, now you see how we are going to measure that. Now you see, this is connected in series. You see here, this is connected this one with the buzzer, and this is in series connection. You see, in one line. You see, this is not in parallel but in series connection. Now you see how we are going to make the we are going to measure the current. Now you see, you can see the display here, right? Now you see how we are making. Now you see, if we touch it, the buzzer will give sound, and we want to measure the current in this circuit. Let us check how much current we are getting. Now you see, we have connected this buzzer in series. You see, this is the negative probe, right? We have connect this negative probe with the negative wire of this buzzer, and the positive wire is connected with the positive terminal of the cell, right? We have connected the positive terminal of the buzzer with the positive terminal of the cell, and this is our positive probe of the digital multimeter. Now if you connect it, we can see that we have connected this in series. You see, like series in one line, that is in series connection. And we put check this how much current we are getting. We have put the range on 10 ampere to measure the current in this buzzer. 0.01, right? 0.01 ampere. Here we are getting 0.01 ampere, that is 0.01 ampere. Now we will change this range from up to 20 milliampere, right? Here you see, that is we put this range up to 20 milliampere, and now we change the, we measure the current, how much current we are getting. 0.01, right? We are again getting 0.01 milliampere, right? If we put it in micro, 2000 micro ampere, now let us check whether we are getting. No, we are not getting any reading, right? Now if we put this in 20 millivolt or 200 millivolt milliampere, 200 milliampere, let us check the current here. 0.1, that is 0.1 milliampere we are getting in this circuit. You see here, we are getting 0.1 milliampere, right? 0.1 milliampere we are getting in this circuit. That is, when the buzzer is making sound, it gives a 0.1 milliampere. Let us check once again. 0.1, you see, that is 0.1 milliampere we are getting, right? You see, we are getting 0.1 milliampere current in this circuit, right? This is a series connection. Are we cutting for this series connection? We are getting 0.1 milliampere, right? You see here, we are again trying 0.1 milliampere we are getting, because this is milliampere, right? If you put it on 20 ampere, 20 milliampere, we are also getting in the same way, that is 0.01 milliampere we are getting current in this circuit. And you see, this is connected in series. Now we will replace this buzzer with another motor or another LED, and we'll check how much current we are getting with this LED. Now let us see how much current we are getting with this LED. Now here we are changing this buzzer and put an LED, and we'll check how much current we are getting in this circuit. And you see, we have put this also, this LED also in series connection, right? Let us check how much current we are getting. You see, this is the negative probe of this LED. We connect with the negative of this LED, you see here, and we'll connect this with the positive terminal of this one, right? And now we'll see how much current we are getting. We put this in 20 milliampere. Let us check. You see here, we are getting 0. It is, though it is fluctuating, it is 0.3 milliampere, right? Or 0.4 milliampere we are getting to measure the current here. It is fluctuating, though the current is fluctuating, it is DC current, you can see here. And this is 0.04, 06, 05, 02, 03. It is fluctuating, and we are getting 0.3 milliampere, right? If we put it this range in 200 milliampere, even then you are getting the same value, that is, we are getting 0.3 to 0.7 milliampere current, because the current is fluctuating in here, right? Here you see, we are getting 0.4, 0.3, 0.6, 0. 4 milliampere. Getting this current because we have connected this in series, right? In this way you have to connect any load in series to measure the current. Here now we'll show you how we are getting the current. You see here the current is nearly 0.6 or 0.3 milliampere current we are getting while making the LED glow. We are getting 0.4 to 0.5 milliampere current. We have connected these in series. Now you see how we are giving a motor and check how much current we are getting in this digital multimeter. You see, this is our motor. With this motor we will check how much current we are getting. Right? Let us check. Now we will check with this motor how much current we are getting. Now you see how you are going to connect this motor within this circuit and we will measure the DC current in this case, right? Let's see, we are connecting this with the motor and see how much current we are getting in this series connection. Here we are replacing this LED with this motor and let's see how much current we are getting, and you see that we have connected this motor in also in series connection to measure the current. Remember that to measure current you have to put the load in series connection, only then you can measure, otherwise you cannot measure, right? Here you see we are connecting this with this wire. You see here we have connected this motor with the in this circuit, and you see whenever we switch on it will rotate the propeller and we will find how much current we are getting in this circuit, right? For that we have to put this motor here and we will see how much current we are getting, right? For this you have to fix this motor here. After that we will see how much current we are getting to this connection. We are fixing this motor in this box. After that we will check how much current we will get. Right, we have fixed this one and see now how much current we are getting. Right, now you will see that we connected this motor in series to this one and we'll check how much current we are getting. You see here we are connected this motor in series. After that we will check how much current we are getting in this circuit. Remember that whenever you want to measure the current you have to put the load in series connection to measure current. Now see, we have connected the motor in series connection and we'll check the current. You see here, we have put this knob on 200 milliampere and let us check how much current it is flowing when the motor is running. Let's see how it is, how much current we are getting. In this way, you can measure current in a series circuit. You can use a motor or LED or buzzer, anything you can use as a load and you can measure the current. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.